Hello everyone, welcome back to the channel. My name is Sumit and today we are going to discuss one more important interview question. So the question is that how we can convert decimal number to binary number. Okay, suppose I have one number, so if I write int number equals to 15, so this is a decimal number, so binary will be, it will be 1111 like that. Okay, so one more thing, let us discuss in depth that how usually we do, like, so this is a conversion, this is how basically we do the conversion of decimal to binary. So decimal of 125 is this one, as you can see in the screen. So to convert a decimal into binary, we keep on dividing the number by 2 and we will get the remainder. So this part is the remainder part. Okay, so like that you are getting all the remainder, and after that what you are trying to do, when you get the last digit as 1, okay, so again you will write that this number is here, and what you will do, you will go like this: 1 1 1 1 0 1 0 1. So this is the same one. Okay, so let me show you one more. I think okay, so if you see here, like this, so if you see how they are doing, first dividing the number by 2, and then they are going from bottom to top. Okay, so how we can achieve the same in Java programming language? So for that it's very simple. So what I will do, I will see this image and write the program accordingly, so that we will not forget that if we have the basic idea, then we will be, it will be very easy for us to write the program. Okay, so suppose this is the number, or let me take this number only. So the number is 100. Okay, so number is 100. Okay, so I will run one for loop. So for int t equals to number, and I will say t should be greater than 0, so this will be our stopping condition. Okay, so and then I will say t equals to t by 2. Okay, so if you see this third condition, okay, so we are getting some error. Okay, it should be 4. Okay, so if you see this third condition, t equals to t by 2, this is the same step we are doing everywhere, right? Dividing the number by 2 every time. Okay, so that's why I've taken this third condition, t equals to t by 2. And now if you see, I need to get the remainder. So this is the remainder. Okay. So when you divide 50 by 2, you will get 25. So to get the remainder, we need modulus operator. Okay. So to get the remainder, we need the modulus operator. So I will say int, let me take one variable equals to t module by 2. Okay. T module by 2. So this is my last digit. Okay. And let me take two more variable, int b equals to 1 and int sum equals to 0. Okay, then after that, once I will get the last digit, I will say sum equals to sum plus a multiplied by b. Okay, so a is our last digit, and what is b? So here I will write b equals to b multiplied by 10. Okay, so I will debug this program. You will understand that what all these operations are performing. So basically I am calculating the sum at each and every step. Okay, so this number will become like this, 1100100, and here I am multiplying it by 10 so that we can add all the number like that. Okay, so let me debug this. You will be very clear what I'm trying to do. If I debug this program, okay, so yeah, so first of all, number is 100. 100 is greater than 0. We will go inside. What is, when I divide the number by 2, when I module the number by 2, I will get 0 as the, sorry, it's not the last digit actually, it is, you can say it's the remainder. Okay, it's the remainder. When you module a number by 2, you will get the remainder. Like suppose for the first time you will get 0, then 0 like this. So again I will debug the program. So okay, so t module by 2, so you will get 0. Okay, when you module the number by 2, 100 by 2 modulus, you will get the remainder as 0. So again we got 0, and I'm saying sum equals to 0 plus a is 0 and b is 1, so sum will be 0. And then I'm saying b equals to b multiplied by 10, so b will be 10. Okay, so b will be 10, you can see on the right side. Now again, once this condition will execute, t by 2, what will happen? If you see this, let me run it. So if you see what is the number now, it is 50. Okay, so now number is 50. When you module 50 by 2, it will give you 0 as the remainder. So now again remainder is 0. Okay, so this is the same thing, like again we got the remainder as 0. Okay, here you can see the mouse pointer. So now I will go after this. So I am saying 0 plus, in before this step some value was 0, so 0 plus 0 into, because this will be 0 again, into b, so again it will be 0. Okay, so b's value is 10, but still it will give you 0 because 0 into 1 is 0. So now it will give you 0, and after that b value become 100. Now again it will be 12. Okay, sorry, not 12. Yeah, so after 50, when you divide the 50 by 2, it will give you 25, remainder will be 0. To get the remainder, we need to module the number by 2. Okay, so what it will be, it will be again, no, this time it will be 1. Okay, because when you module 25 by 2, it will give you 1. So now I'm saying 0 plus a multiplied by b. So a value is 1 and b value is 100. So what it will give you can see on the right side. So now we got this number 100. Now b value will again multiply by 10, so b value will become 1000. Okay, now again this condition will execute at the end, and this will be checked. So if you see, now number has become 12. Okay, so is 12 module by 2, what will be the remainder? It will be 0. Okay, you can see the remainder will be 0, and I am saying 100 plus 0 multiplied by 1000, so again it will be 100. Okay, so now b value will become 1000, 10,000, sorry. So now again I am dividing the number by 2, so it's not executed yet. So once I implement this step, so you will see it will become 6. So now 6 module by 2, it will be 0 again. So now sum equals to 100 plus 0. Okay, so it will again be 0. Now b value will become 1 lakh. Okay, now if you see it again, it will execute. Now t value will become 3, and 3 module by 2 will give you 1. So sum will be 100 plus 1 into 1 lakh. Okay, so this is how it will work. Now you can see the value, slowly and slowly we are getting the our desired binary number. Okay, so now b value will be again multiplied by 10. Now t equals to t by 2, so what will be the, it will be 1. Okay, so 1 module by 2 will give you 1 only. Okay, so what is the output? 1. Now I'm saying sum equals to this number plus a multiplied by b, so a will be 1 and b will be this number. Okay, so now if you see, is it the required binary? Not yet, I guess. So 1100 100. So 1100 100, I guess we got the answer. So now b value will again increment, but what is the value here? Okay, t equals to 1. Okay, so when you say 1 by 2, okay, when you say 1 by 2, you will get 0.5. At the end you will get 0.5, but as both the numbers are integer number, the 0.5 will be trimmed and 0 will be the output for this case. Okay, so t value will have 0, and 0 is greater than 0 condition false, so we will simply come out of the loop. Okay, so I should have printed this some value, so you can give some other name. Okay, system out.println binary is, okay, so binary is equals to plus sum. So let me run it. Okay, so you can see this same output we got. So we have successfully converted one decimal number to binary number. So it is 1 1 1 0 0 100. So let me take one more. Let me take this number. Okay, so if I say 172, we are just checking whether our program is working. So if you go down, what will be the output? Yeah, this one. Okay, so we should get this number as our output. So let me write this output here only. So let me run this program and see whether it is equal to this one. So you can see 1010 1100. Okay, So this is how you can convert a decimal number into binary number.